Unit 2, Pumps Overview. This training program deals with the various types of pumps commonly used in a wastewater treatment plant. While many factors determine the types of pumps that will be used in different parts of the plant, the main consideration is the character and nature of the fluid to be pumped. Incoming wastewater, for example, has to be considered as more than just water. Wastewater may contain paper, rags, sticks, bottles, and so on. A pump can be damaged by these objects. Proper maintenance and regular cleaning of bar screens will reduce this problem, but it is still important to use a pump that is less susceptible to damage and clogging. One type of pump commonly used in this part of the plant is a specially designed centrifugal pump that has large openings that allow solid objects and stringy materials to pass through the pump without damaging or clogging it. This type of pump is called a non-clog centrifugal pump. Incoming wastewater can also contain large amounts of sand and grit, especially if the influent includes stormwater from a combined sewer. This grit is abrasive and will damage pumps unless they are specially designed. For example, pumps used at the influent end of the plant would have impeller designs that are made specifically for grit-laden liquids and would be constructed from abrasion-resistant material. While strict enforcement of sewer use bylaws will decrease levels of corrosive industrial wastes and solvents, occasional high concentrations of very corrosive wastes in the influent wastewater will also affect the pumps and other equipment. Within the plant, other kinds of pumps are required to deal with thicker fluids, such as sludge. The solids content of sludges will vary greatly, but generally sludges have a higher viscosity than water. This means that sludges are fairly thick and have more resistance to flow than water, but they can still be pumped as a fluid. If chemical conditioning of sludge occurs at the plant, an even higher sludge viscosity will result. The type of pump used to pump sludge depends on the viscosity of the sludge. For example, positive displacement pumps are commonly used to pump thick sludges, and centrifugal pumps are used for thinner sludges, such as return-activated sludge. This slide lists the commonly used types of wastewater pumps. These are the types of pumps this course will cover. Centrifugal pumps are the most versatile and have many uses around the plant. Centrifugal pumps are used for pumping all wastewater flows and all thin sludges. For thicker sludges, recessed impeller centrifugal pumps may be used. Pumping efficiency is reduced, but recessed impeller centrifugal pumps are more resistant to clogging than other centrifugal pumps. Another major type of pump is the positive displacement pump. Larger positive displacement pumps are commonly used to move heavy sludges, while smaller ones are typically used as chemical feed pumps. This course will discuss these varieties of positive displacement pumps: plunger, diaphragm, progressive cavity, rotary lobe, peristaltic, and the screw pump. Typical wastewater treatment plants use other pumps as well. An example of another type of pump is the airlift pump. They are low-capacity, low-head pumps, typically used to pump thin sludges. Later, this course will discuss the pumping stations which house the large pumps that collect and transport wastewater to the treatment plant. Pumps are the heart of the entire treatment system. Without proper circulation, the system will be ineffective and can even stop functioning. In addition to treatment process control, the operator will always be concerned with the proper operation and maintenance of pumps at his or her treatment plant. His or her functions and duties will include starting and stopping pumps as flow or operating conditions demand. As you will see in this program, operators will be required to perform many other pumping-related duties as well. They will want to know how to control the operation of their pumps. This means that the standard duties will be noting changes in running sounds and vibration of pumps, noting bearing temperatures, performing pump startup priming when necessary, checking suction and discharge gauges, observing flow rates, tracking motor readings, including amperes and hours, and maintaining other records of pump operation and fluid sampling as required. An operator will also want to be able to properly maintain and replace certain components. This means that he or she will be lubricating parts that wear, checking alignment, and cleaning and repairing drivers, drives and pumps, as well as changing packing or seals, replacing impellers and wear rings, and unclogging the pump. Always refer to the manufacturer's instructions for details on operating practices that are specific to a certain manufacturer's equipment. Generally, noise, vibration, and heating are all indications of a problem and should be investigated immediately. If pump performance is not satisfactory, it may be necessary to run a pump performance test, possibly with the aid of the manufacturer's representative. Before this course discusses different kinds of pumps in detail, it will examine some components which are common to all pumps. These components are the motor, shaft, coupling, and bearings. Note the motor, shaft, coupling, and bearing in this diagram. All centrifugal pumps have an additional common component, the impeller. The impeller inside of this pump is highlighted. The power source for the pump is usually an electric motor. The motor is connected by a coupling to the pump shaft. The bearings hold the shaft firmly in place, yet allow it to rotate. The bearing housing supports the bearings and provides a reservoir of lubricant. An impeller. In the centrifugal pump, the rotation of the impeller creates an area of low pressure near the center, which allows atmospheric pressure to push more fluid through the suction into the pump. The rotation of the impeller vanes then throws the fluid out of the discharge. As this is a horizontal pump configuration, the shaft is horizontal. The pump assembly could also be arranged vertically. This photo shows a vertical centrifugal pump. In a vertical configuration, the motor is frequently further away, possibly even in a room above the rest of the pump. This requires a longer shaft and more bearings to support and steady the shaft. Placing the motor further above the pump protects the motor from potential flooding. Note that the horizontally and vertically configured pumps have the same basic components. In the 4 remaining units of this course, we will discuss specifics regarding several types of pumps. The first stage of the program will deal with motors, couplings, and bearings. The following 2 units will investigate different types of pumps associated with wastewater treatment systems. The final section of the program will focus on pumping stations. This completes the introductory overview.